Bianca, welcome to the Astroben podcast. How are you?
I'm very good, Ben. Good morning. Thank you for having me.
As we record this on May the 5th, I feel we should start the conversation by saying May the 4th be with you for yesterday.
Yeah, exactly. And I'm sure it was with you yesterday.
I know. We just talked about it before hitting records, but Christina Corp, who's a former guest on the Astroben podcast, organised an amazing series of events in London to coincide with I think it's to sort of symbolise the handover of the Apollo era to the Artemis generation. So
Mm.
Christina, otherwise known as the astronaut wrangler, brought together a load of astronauts from, even the Apollo program, like Charlie Duke, and some of the newer pilots like Jared and Scott Petit, and some of the guys from the new Polaris Dawn mission. So it's quite a sort of powerful event, really. But I went to an event yesterday, a May the
Mm.
Fourth party. So apologies if I sound a little bit hungover. But it's quite interesting the
Yeah, well, he
space.
did, and I missed out.
But it's quite interesting the space industry because we have like May the 4th, and then we have Yuri's Night. Like we have like two quite
Hmm.
big like space themed events like right next to each other. Um,
We
but
do.
anyway,
I mean, there is never like something missing in the space industry to celebrate. Every day is something new, like the asteroid day or the Apollo 11 landing. Now that hopefully we will have more things related to women because it's all about men.
yeah, no, exactly. I was going to ask you about that because you are the co-founder of Space Dots, which I'd love to hear what it is from the
Hmm.
horse's mouth. But you're I haven't met many female founders in the space industry. Like how do you feel about that? Is that something that you sort of conscious of when you started off?
Mm. So I'm not surprised you haven't met many. In fact, when I was giving my TED talk a couple of weeks ago, that's exactly what I was representing. It's only 12% of new space founders identify as females, and it's funny how I didn't feel like being a minority because since I started, so my background is in space and astronautical engineering. And I come from the south of Italy, and obviously we were a minority when I started studying. However, that never kind of put me off. And although I knew it was a very male dominated environment, I never thought that to be an obstacle. But obviously, then, like moving from my country and then moving across Germany now to UK and starting my own business, I started to realize how few of us there are. Literally, I am probably one of the few, I think we can count on one hand the women in Italy who started a tech company, and I think I'm the only one from the south of Italy, probably one of the two or three. So that's really very very few. And how I feel about this is that I feel the responsibility, if you may, to represent not only just my own business and myself in the space industry, but all the other ones. And this started especially when I was working at Airbus Defence and Space. When I moved to London, that was like 5 years ago. It was because I had just got a role as product manager on big telecommunications spacecraft at Airbus Defence and Space. And I remember the first week I was thrown in the boardroom, and I was the only woman under 30, non British, in a room filled with dozens of white male over 50 guys. And I was like, where are all the other ones? So it felt to me that somehow I have to empower myself to speak and to voice out the the fact that we are a few people, a few women in the industry, but at the same time that's not what's going to be the norm in the future. And hopefully just voicing out what I do and making it sound like it's awesome for a woman to do that. Hopefully we will not be that few in the future. This is basically started as my own mission, reason why I really appreciate when you invited me on the podcast, and the same with all the other interviews, because there is need of representation. And the space tech CEO is always seen as, represented by the usual three main names in the industry, as we know. And it is true, they are the most relevant because they're billionaires and they've started in different ways from different backgrounds, but that doesn't mean that a woman like me or a guy like you can't be part of the space industry as space tech CEOs. So this is really important for me. Besides, obviously, the tech, which I love because I'm an engineer, so I need to love the tech.
That's inspiring, and I completely agree with you. Well, let's talk about the tech of Space Dots. So what is Space Dots? Because I think it's a really cool name, but like everything in the industry, Dots probably stands for something.
Exactly. It stands for something which is a mouthful. So it's dimensionally optimized technology satellites. And basically, what we do is Pico form sat, which is, I mean, if we look at a smartphone size, so like let's say a shape form of a bit bigger than an iPhone, so a 10 by 10. And what we do is miniaturized testing labs for tensile, mechanical, and thermal testing on orbit. So this is the very first miniaturized tensile lab and thermal labs for extreme environments. And so basically this whole solution came about with my two co-founders who I've met actually at Airbus Defence and Space when we were working there, because we were all working in the product management division, and I was on the thermal solutions and the other two, Jim and James, were on the mechanical and propulsion. And what we realized is that although we could always, obviously you have like, you know, a certain amount of budgets from Airbus Defence and Space, and you have the network and it's a big corporation, most of the products and the advanced materials that we were managing with other partners, which were SMEs or startups, most of those wouldn't really see the space. And this is because there is the huge procedure of space qualification. As probably most of the people know in the industry, you need to go, there is a wide range of technology readiness levels. And to get to the stage where your technology, your advanced materials, your electronics, whatever, can be used for a space mission, it needs to go through that huge qualification that starts with testing in simulated environment on Earth and then being obviously demonstrated in space. But to do this first flight heritage, it's a kind of a paradox, because if you don't have money enough to go through your entire development and then to fly your advanced material or whatever components, now independently of what's the shape or size, even if you want to fly on a CubeSat, it's still hundreds of thousands of euros or pounds that you need to pay to have that first flight demonstration. And also it takes time. Most of these demonstration for advanced materials, for example, they happen on the International Space Stations, where you have basically they are exposed to the radiation environment and the thermal cycling on a low Earth orbit to really understand how is the behavior and if there is any deterioration of that material. However, none of them is incorporating the entire process, going from the mechanical to the thermal to then the radiation environment. So you just stick these elements, little samples of your material, whatever that is, on a carrier that goes to the ISS, and then you wait maybe 12 months, 13 months until you can probably get the sample back, or you just get some information out of those. It's a very long process. And when I was talking when in our first customer engagements, for instance, we have one of our customers who said we had developed thermal coating, which is a black thermal coating. And from the day of concept to the day of demonstration, nearly 8 years have passed, which means our technology is probably going to be outdated. And we obviously lost big primes customers because they said, if you had already flown, we would have been very, very interested to apply this to our programs. But because you haven't, it's been such a huge span of time from concept to demonstration, we are not using that. So with Space Dots, we wanted to reduce not only obviously size speaking, being miniaturized, but really giving this service which encompass the entire qualification from mechanical to thermal radiation, and making it as such that it can be hosted to any CubeSat spacecraft from LEO to MEO to GEO to cislunar or interplanetary missions, and can be given can give you the results straight on, so live when you are on orbit, in clearly less than a year or two, and for tens of thousands rather than for hundreds of thousands. In this way, we want to make sure that any other SMEs, academic or startups who want to also expand or accelerate their advanced materials in space can actually do it without having to spend like thousands or millions, and then realize at the end of their development, oh, actually that didn't work, we have to iterate again. So we cut through the iteration and qualification process. We give them the chance of spending tens of thousands, understand if that works, and if that doesn't, they haven't really lost the entire budget. So it's, we're talking about democratization a lot in the space industry, which is a hype word, but this is literally where it started. We said it's really unfair, especially myself. I'm the first one saying everybody can go into space. Every business in 10, 20, 30 years is going to be part of the space industry. But how do they do if they don't even have an idea of how to get their advanced material basically tested in space? So we came about with Space Dots, and that's in a nutshell what we're doing. And we've now starting with the ESA Business Incubation in the UK, Narwhal, and we'll be launching our first prototype Q1 next year. And we are in the full fundraising race also. So it's an exciting time.
Absolutely.
Everything is happening at the same time.
It sounds really cool. And I think that's a great idea, sort of, lowering the barrier for entry to space. Because there'll be a lot of companies that have an idea and, even hundreds of thousands of dollars is just too unobtainable. So are there any limitations, though, to the Pico sats? Because, what are there stuff that you can only do when a satellite is a certain size? Because I'm just thinking, like, you've got CubeSats, you've got microsats, you've got picosats. So, I mean, what experiments can you do on them? Can you replicate pretty much anything just on a smaller scale?
So what we are working at the moment is exactly that. Our first prototype is going to be a tensile lab. So for the tensile strength of a prototype, generally that applies to aluminum alloys, 3D printed alloys, plastics, or even high tech fabrics, for example, for being used for parachutes on an interplanetary missions, or for fabrics for astronauts' mission or human space programs. And that kind of testing lab needs to replicate exactly, in an obviously smaller scale, the same data, the same strength of tensile strength, the same parameters, according obviously to all the standards that apply in the industry, than a tensile lab as a tabletop tensile lab, basically.
Yeah.
So you are literally being exposed to vacuum directly, and you are at the same time understanding how your small components, we are talking about 2-3 centimeters, let's say, which is a fair dimension for a sample to be tested and cracked in space. We are giving you that straight into vacuum the mechanical behavior of that sample. So we are talking these kind of advanced materials, nanomaterials, of course, carbon-based, graphite-based, all the new avant-garde CNT-based materials. And this is the kind of samples that we will be testing. And obviously, this is our first prototype. In the next ones, we will be doing many other mechanical testing, but also thermal conductance testing, thermal conductivity test. And again, it's an emerging market that we've been seeing with the miniaturization of testing materials and nano components in space. And again, what it does is that instead of going through different stages, first you do the mechanical test, then you do the tensile, then you do the Young modulus, blah, blah, blah. Then you go into a vacuum chamber. You're doing all of them at once, which means also the ground-based testing system may be reduced or streamlined, or again, made it more efficient. And the entire segment where we realized to be part of is the in-space services and manufacturing, which again it's very new. The new space ecosystem and the economies is just developing at a very, very high pace. And we ourselves had to struggled understanding competition or understanding, the market that we can win or the market that we can create. But it's extremely exciting just to understand that this could shift completely the paradigm of how you are qualifying your materials. Just because you have in a pocket size kind of lab that can stick on any kind of rockets or launchers or satellites on any orbit, you can literally understand how your material works. That's just not limited to LEO or to the ISS, which will be decommissioned anyway. So we needed, as a space community, we do need a commercial plan, which is not just relying on NASA, ESA, or the Roscosmos about the fate of the ISS. We need to understand commercially how do we want to help more companies get onto LEO and demonstrate their technologies that then are going to be used for space programs, for interplanetary programs. So this is where we are going. It's a very niche one, which is taken for granted because everybody says, okay, we do rockets, we do these. But before even making a rocket, you need a material. You need material science that is backing your own program, and you need testing and you need validation. So this is where we're at.
That's really cool, and it makes a lot of sense. I was just thinking about space junk is another very hot topic at the moment. When you launch these space dots, what happens to them once they've finished the ends of their mission? Because I assume they don't have any propulsion to them. So do they just disintegrate back into the atmosphere? Is that something that's built into the mission plan?
Because being very aware of the space junk, so what we've done is they are not independent satellites, at least not the first generation, because the first generation is going to be hosted as a payload onto another satellite. And what we are doing, what we also realize is that most of the CubeSats and mini-sats and nanosats that are sent into space, they have a lot of unused mass. Meaning there is a lot of space which is empty in those CubeSats just because of the allocation of payloads or what customers want. So what we are doing, we are filling in the gaps of those CubeSats or nanosats. So we are like little drones. And what we can do is that we can just being stuck up from one sample to even like 32 sample for an entire 1 year CubeSat and be sent into space, so that we are not adding more junk into space. We are just filling in the gaps of what's there already. And in a way, we are kind of, maybe, this is something that we thought, we are kind of bypassing the problem of the space junk ourselves, because that's responsibility of who is carrying us into space. But that's how we had to do it for our first generation. The second generation is going to be different, and we will have to think about when we will become an independent satellite that goes probably more like interstellar or interplanetary. We will have to think about the risk mitigation for space debris. So onto LEO and GEO orbits, we will be filling space of spacecraft which are already there.
That makes sense. That's awesome. So last year, I think you've been supported by the UK Space Agency. What does that help consist of? Because I've had Paul Bate, the CEO, on the podcast, and he is brilliant. I think he's a really great leader. And obviously, as a UK citizen, I really want the UK Space Agency to, grow tenfold. So I'm just intrigued. How did they get involved with Space Dots, and what was that support like?
I was amazed by the support that came from the UK Space Agency. So the story is that we incorporated our company the 7th of January last year. And in March, because I'm obviously always on LinkedIn looking for what can be done. I saw from the UK Space Agency this advert saying that there was a new LEO Space Accelerator program, and obviously everything is in line with the role that the UK Space Agency wants to have now as a leader in the space industry globally. And I was like, wow, that's cool. Okay. And I thought, we're just born. So let's see what happens. And I remember speaking with one of my co-founders, and he said, oh no, we're not ready. Come on, it's just too early. And I said, of course we are ready. We've been talking about this for 2 years. So long story short, I remember the day before the deadline, I was in my bed and I need to apply for this one. I applied to that thing on my phone. The day after, I got an email saying that we had been accepted to give a 60-second speech, and then probably we will go like through the program. So this is what happened. I received the email that we were called to give a 60-second speech. I gave the 60-second speech, which was very daunting. and after a week or 10 days, we went into the acceleration program. And that's been amazing. Amazing in the terms that obviously this was also supported by Entrepreneurial Spark. And each entrepreneur, each of us was assigned to a business coach. And Jeremy Ambrose was my coach at the time. We are still in touch, and they're still like supporting a lot our mission. And it's just been amazing how having those one-on-one conversation and then the networking sessions, workshop, masterclass, it did accelerate us a lot. When we got out of that program, which was the Leo, and then for the next 3 months, we were also accepted to the continuation of that program. We were incorporated with a shareholding agreement. We had lawyers, we had proper accountants, we had a proper funding strategy. We were ready for applying to the ISA, Pico, or all the other public grants, something that I had absolutely no idea. Again, when you start your own business and you're coming from a background which is obviously not business, because I'm again coming from a background which is purely tech. I didn't know many things. I didn't know really the basics of business administration, and that was so helpful. Like I'm so grateful to that.
What have you learned about yourself in your entrepreneurial journey so far? I know it's only been a year full time, probably a bit longer kind of conceptually, but what have you learned about yourself? Because it's not easy. I think a lot of people think that it's like an easy thing to grow an idea and a company.
Oh no. No, it's not easy at all. It's the opposite of being easy to say. It's an understatement. What I've learned about myself, first of all, is that I have to. So you become stronger in the face of rejections and failures. And I had to understand patience. I'm a very impatient person, and you need to understand patience because not everything moves at the pace that you want to. Not everything happens yesterday. Not everybody is ready to do the things at the same time as you want to. And that's the thing. It's like it kind of humbles you as a person because you have to just sit there and do the job when nobody's watching. Although, again, when you look at CEOs, you seem like it's glamorous. They're always like on that page or that magazine or doing that talk. That's just what people see. But behind the scenes, there is a work that is like late nights, sacrificing lots of social relationships, to be fair. And I had to be prepared to do that. But because I've been in a family where all of them were entrepreneurs, like even my brother is an entrepreneur when he started his business when he was 23, I'm kind of used to the chaos and to the unknown. But at the same time, then, if I'm used to that, it doesn't mean that my co-founders and my employees or the ones that are supporting me are able to do that. So, and I had to learn not to take for granted the fact that because I know something and I know what I want to achieve, everybody understands or reads my mind. So again, it's a very humbling position, and you start to understand a lot about relationships because you don't want to be a manager. You are not a manager. You have to be a leader. Your vision has to inspire people to work with you, and you want to inspire the right people because you want to create the culture that really feels right for your mission, for your team, for the future of the products you are creating. It's not just about tech. And that takes a lot of sitting back, understanding, listening, enabling your partners to do things when there is some problem, when there is a roadblock. That's really, I've become a way more mature person, to say, as an entrepreneur, because it feels like it's like you have a baby and you have to grow this baby from, you're birthing the baby, and the baby doesn't know where to go, doesn't know how to talk, doesn't know how to walk, and step by step you have to learn together with the baby how to guide the baby, how to guide every step of its life. And it's the same with the company, and it's the same with your co-founders and everybody who's coming into your team. You learn together. And the other thing I've learned is asking for help, because I don't know everything. I will never know everything. And some days are really hard. Some days are not, I don't feel like at 100%, I'm maybe at 10%. And I've learned to do this with my co-founder, both of us, where we just have to be very clear about the fact that that day is not a good day and we need help. So it's a beautiful experience, to be fair. As a human being, it's humbling. It's beautiful. It's beautiful. It's a beautiful journey, but it's not for the faint-hearted at all.
That's inspiring, and I like the way you took the it's your baby analogy, and getting it to crawl, to walk, to grow. I think that's fantastic. So you're hoping for a prototype to be launched in Q1 next year. What will that prototype consist of? Is that something that you can say, or because I always thought about, because every space tech company's got to start somewhere. How does it work? Do you have to approach a launch provider? Do you have to, there's probably quite a big lead time on something like that. So what's the process, and are you excited about it?
Yeah, so how it will look like, it will look exactly like our product. Obviously, it's a minimum viable product with a first user, a first customer sample, where we actually need to understand if our entire scope of reducing a tensile testing rig to such a small precision engineering scale works. So it's not going to give us, it's just a minimum viable product. And it's going to look like pretty much a smartphone, just bigger. So a 10 by 10. So a 0.1 U CubeSat for the space industry standards. And what needs to be done, it's a lot. We have now been talking, it's been more than a year where we've been talking with multiple people for a ride share, because again, as we are a hosted payload, we need to ride share with somebody. So it's first of all understanding who is gonna be that CubeSat or that nanosat that can carry on with the right ride share. What's the pricing? Where are they launching? Who will be the launchers? How much it's gonna cost? How long it's gonna take? Also, because before launching, obviously, you have your own prototype. Again, let's just talk about the smartphone, and you wanna integrate that smartphone into a CubeSat. There is an entire procedure to do that before, because before going there, even yourself have to be certified to fly onto that program, onto the CubeSat, because you don't want anything that is outgassing, where outgassing is obviously like gases coming out of a material which has not been fully baked out in a vacuum before going into vacuum. It's all of a paradox. It's a bit of a paradox. But anyway, before going there is probably a span of 6 months where you have to do all your on-ground testing check, pre-flight check. Then you have the integration onto the rideshare mission, the rideshare platform where you're going to be attached to. And then that entire satellite, which is carrying your own baby, needs to go onto a launcher. And then there is the whole launching procedures, and then you're launched. So it's a long process that we had to start literally even before being born as a company. And the fact that I've been but also with my co-founders, we've been in the space industry for totally 30 years. amongst us, because we are three, helped us understanding who could be the partner, who could be the supplier. But still, we are still in negotiations. We have signed a partnership with Siderius Space, an Italian-based startup. They are doing small launchers, small rockets for small satellites. Again, they are developing, so we will be launching a prototype with their first prototype. But obviously, because there could be a failure from both sides, we need to have a backup. And the backup is very expensive, and it's taking ages for us to pin down the right negotiations and the right contract. So it is a very long process that starts even before like you have the first numbers on your paper.
Wow. Well, I wish you luck with the process. I'm sure it's going to be a stressful
Thanks.
second half to the year, but hugely
Oh
rewarding
God,
if you can
yes.
get there. um, it's been great to chat to you. Just before you go, it'd be nice to hear you're an entrepreneur. I think as an entrepreneur, sometimes it's hard to, because you don't want to come across as arrogant, but it's
Mm.
nice to say out loud, like, where you want to see yourself in 10 years' time. Where do you see Space Dots, and what role do you see them serving the space economy as it grows over the next decades?
I think I had these questions also another time, and I said that the most beautiful thing for an entrepreneur or anybody who's giving a solution to the market is seeing how many of those people, how many of those customers you've enabled to get into space, at least for me, because this is what we want to do. How many of those customers we've been able to get into space who and never thought before they could do something for space. And again, Space Dots is born as a space company and upstream services. But what we want to serve is all the customers who are like ground based, like majority of them who are doing material science or any other experiments in extreme environments, who had never that can be compared to obviously the microgravity and then the space vacuum, like submarines or geology near volcanoes or lava tubes. I would be so happy to see how many of those we've enabled who had never really had the possibility to think my material is going to go into space and is going to provide an advancement for the next Artemis mission, for example. This is really what I want to see. I want to see most of those people who thought space is not for me to be able to say, actually, I've contributed to the lunar mission. I've contributed to that Mars mission. This is really my grand vision, the way I want to serve the customers and all the people. Also because I'm the first one preaching everybody can go into space. So I had to do something about it.
And you're also inspiring the next generation of female CEOs in the tech industry, which is incredible. So
I really hope so. I need more of those girls on the boards. I can't be always the only one.
I agree. Well, look, it's been great to chat to you. I would love to chat to you again in the future once you've had that first launch. And thank you again for coming on.
Thanks to you, Ben. It's been great. You have a great day.